So, molecular formulas. Once you learn how to interpret their names, writing the formulas for covalent compounds is actually quite simple. However, in order to be able to extract the information provided by the words, you must first understand how the names are formed. So, for binary covalent compounds, the names are always as such. There will be two words. The first word is a prefix plus the name of the element, and the second one is the prefix plus the name of the element with the suffix "ide." These prefixes are an essential component of the naming process because of the many ways that covalent compounds can form, so this helps to eliminate confusion. So here's the list of the first 10, whose names are derived from Greek numerical prefixes. So there's mono for 1, di is 2, tri is 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So now that you know the naming process, you can translate these words into formulas. So here we have our first example, diboron hexahydride. So let's first begin by breaking the words apart into more digestible chunks. So we have di as the prefix, boron, hexa, and hydride. So we first take the word di, and we check our chart, and this translates to the number 2. So we're going to write the number 2 down. Then boron, we have to use the chemical symbol for this, and so we check the periodic table, and boron has a chemical symbol of B. So we write that down too. So now that we have both parts of the first word, we can combine these two. Now this is important. The symbol and the number change word order from the word to the formula. So the 2 that was a prefix is now a subscript, and it must follow the symbol in order to be properly understood. Therefore, instead of 2b, we write b sub 2. Now, for the next word, we take the same steps. We check hexa, and we check our chart, and that translates to 6. So we write down a 6. Then we take the hydride, remembering that the suffix "ide" is added to the end of the second word in a compound. So we remove the "ide", and we're left with hydra, and so we know that this is the name of only one element, hydrogen. So we check the periodic table and see that hydrogen has a chemical symbol of H. So we write down the H, and following the rules for the nomenclature, we write down H6. So the final step in writing the formula is just combining these two, which we do by simply putting them together without a space between in the order given. So we just pull these together, and we're left with B2H6. So our next example is carbon tetrafluoride. But when we begin our word breakdown, we see that carbon has no prefix. So this is an important caveat to the rule of naming the words with a prefix. So the prefix mono is only applied to the second word, or the word with "ide" on it, if such a prefix applies to the situation. Take, for example, here carbon monoxide. So the first carbon has no prefix, which simply implies the existence of a single carbon. And the oxygen does have the prefix mono because it's the second word. It's the word with an "ide" on it. So that's the only situation in which the prefix mono will be used. So we have one carbon, C, and one oxygen, O, meaning that the chemical formula here is CO. And another note about this is that there is no number 1, no subscript anywhere in this, because the presence of the symbol implies the presence of the atom, so it's redundant and therefore incorrect to put the number 1 into the formula. So we simply write CO, and it just implies that there's one carbon, one oxygen. Now, back to carbon tetrafluoride. We first take the single carbon, and then we find its chemical C, and we write that down. Next, we take tetra, check our chart, and see that tetra is 4. So we write down the number 4. Then finally, we take fluoride, and we remove the "ide", and we're left with fluor, and that FLUOR is the beginning of only one element, fluorine. And so we take again, we check. Fluorine has the chemical symbol F, so we write down the F. Again, we combine these two using the rules. So we take the number and put it as a subscript of the symbol, and we do F sub 4. Then we take the C, the carbon, and following the rules for the naming them, we just combine it, push it over here, and we list them in order named, so then carbon, then fluorine. So carbon tetrafluoride. So finally, we have sulfur dioxide. Remembering that a first word without a prefix implies 1, we check our chart and we put down a single S for sulfur. Then we take the di, as we already know means 2, and write down a 2 for that. And then we take oxide, remove the I, and we see the only thing that starts with the letters OX is oxygen. So that means we have oxygen with a chemical symbol of O. We combine these two to be O2. Then we push this one over, listing them in the order given, and we have SO2 is sulfur dioxide. Now, as a final summary, the steps are 1, dividing the words into all of their parts, converting the prefixes or lack thereof into the appropriate numbers, converting the suffixes into their original words, and converting the names into symbols. Step 2 is remembering that the numbers will always be a subscript that immediately follows the name with which they correspond. And finally, step 3 is, with their subscripts attached, write the symbols in the order that they're named with no spaces in between.